An insurance company classifies people into three classes. We have low risk, average risk, and high risk. So now we have the probabilities of each of them getting into an accident. So let's see. So let's define each of these first. So this is the low risk people. Low risk. This is average, so let's say medium. And this is high risk. Now let C be the event that they get into an accident. So C is accident. I'm using C for crash. Accident. And we're given the conditional probabilities of them getting into an accident. So those in the average risk category, those in the low risk category have a 5% chance of having an accident. So P of C given L is 0.05. The probability of C given A is 0.1. And the probability of C given high is 0.2, right? So we always want to write down what information we have in a nice form before beginning the problem. And now we're also given the marginal probabilities of each category. So P of L is 0.25. The average risk category, P of average, is 0.6. And 15% are in the high risk category. So P of H is 0.15. So now we're asked, what is the probability that a person has an accident if we pick them at random? Well, these guys partition the whole space, and we're given these, so we're going to want to use the law of total probability. Total probability. Probability. So let's make a nice picture for this. I got this nice graph paper type thing online. Okay, so let's draw out who are the high, medium, and low risk people. Well, we say 25% of the population is low risk, so let's draw over here. So this is 25. So let's say these guys up here are low risk. And then we have, let's see, 15% in the high risk category. So let's use another color for them. Let's use red. So these guys are the high risk individuals. And then we have the average risk people down here, the remaining 60%. And we know that there's about a 5% chance of people in the low risk category having an accident. So that corresponds to, well, that would be 5% of this total area. So if there's 25 squares here, each square is about 4% of the total area. So we'll shade in about that same amount. So that would be a little more than one square. So let this be the accident square. So this is about 4%, and it's a little more. All right. In the high risk category, we have a probability of 20% of having an accident. And there are 15 squares, so 3 squares down here corresponds to, shouldn't get up in that other category. So 3 squares down here corresponds to these accident-prone people in the high risk category. So it's a little more in terms of people, but it's a lot more in terms of the relative area. All right. And now in the average risk category, we have a probability of 10% of having an accident. So there's 60 squares down here. So we want to grab 6. So 1, 2, 3, 4, 5, 6. So there's a lot more people in this category, but proportionally it's still lower than the amount of accidents in this category, but it's still more people overall. So now we want to go back and say, what is the chance that the person has an accident? So what is the probability of them getting into a crash? So the probability of a crash. Right, we're using that color purple. Well, that's the probability of crash given that they're in the low risk group times the probability that they're in the low risk group plus the probability of a crash given that they're in the high risk group times the probability that they're in the high risk group, and then plus the probability that they're in that they crash given that they're in the average risk group times the probability that they are, of course, in the average group. Well, we know all of these probabilities. So the first one, the probability that they crash given that they're in the low group, that's 0.05. Then we have 0.01 for average and 0.1 for average and 0.2 for high. So this is 0.05, 0.2 plus 0.1, and then we multiply by the probabilities being in each group, 0.25 times 0. Let's see, high risk group is 1.5, and then 0.6. So let's just work out what this is. All right. We have 0.5 times 0.25, so that's 0.0125 plus, and then 0.2 times 0.15, 0.03, and then plus 0.06. So what do we end up with? We end up with, this is 0.09, so 0.125. So about a 12.5% chance that they got into an accident, which is pretty close to the average group's probability because there are so many more people in that group than the low and the high group. And that's it.